Okay, in number 29, we've got the sine of 5 pi over 4 times the sine of 7 pi over 12, and we want to use identities to find the exact value of the expression. 5 pi over 4 is a special angle on the unit circle, but 7 pi over 12 is not. So if we look to our identities to help us deal with when we have a product of two sines, but the angles are not necessarily special angles on the unit circle, we can use our sum to product and product to sum identities. So in this case, we're going to be using a product to sum identity. For the product of sines, it's 1/2 times, and then we have the cosine of the difference of the angles. So 5 pi over 4 minus 7 pi over 12, and then that's minus the cosine, and we sum the angles. 5 pi over 4 plus 7 pi over 12. So getting a common denominator, we'd multiply the numerator by 4 over 4, so we'd have 20 pi over, oh no, 3 over 3, sorry. We'd have 15 pi over 12 minus 7 pi over 12, which is 8 pi over 12, and that reduces to 2 pi over 3. And then same thing here, we need a common denominator, so we multiply by 3 over 3, get 15 pi over 12, and 15 plus 7 is 22, and 22 divided by 12 reduces to 11 over 16. So since 2 pi over 3 is a special angle, and 11 pi over, not 16, 6, sorry, 11 pi over 6 is a special angle. That means we can use our unit circle now to evaluate this expression. So cosine of 2 pi over 3, pi over 3 in our first quadrant left-hand trick has a cosine, the x, of 1/2. So on our circle, that's our reference angle, is at pi over 3, and that's 1/2 as a cosine. And then 2 pi over 3 is in quadrant 2. All students take calculus. Cosine is negative here at 2 pi over 3, so it would be a negative 1/2. Okay, then 11 pi over 6, we're looking for the cosine. That's our pointer finger in the left-hand first quadrant trick. And that has a cosine of root 3 over 2 in quadrant 1. So pi over 6, that's root 3 over 2. 11 pi over 6 is in quadrant 4. So this is where 11 pi over 6 is on our unit circle. Cosine is positive in quadrant 4, so it's also a positive root 3 over 2. So we're subtracting and then a positive root 3 over 2. We have a common denominator, so we can combine the numerators. So negative 1 minus root 3, all divided by 2, and then we'll multiply these fractions straight across to get negative 1 minus root 3, all divided by 4. So to check that in the calculator, we're going to compare the decimals for our answer. Negative 1 minus square root of 3, all divided by 4. And the original expression, sine of 5 pi over 4 times the sine of 7 pi over 12. And we see that our decimals are equivalent.